Okay, so we've been talking about different eruption types. We ended up with the Plinian eruption. This is a Plinian cloud from Mount Redoubt in Alaska, 1990. The interesting thing about this volcano is that a guy I've worked with for years, John Eichelberger, who was up at the University of Alaska, was in this crater at the top of this volcano 12 hours earlier. It had been completely inactive, no earthquakes, no nothing. Seemed safe to go in it, so he went in, got a sample with a helicopter, flew out, and then literally 12 hours later, it just exploded with no warning at all. None. Which is really concerning if you're a volcanologist and you deal with hazards. To have an eruption that has no lead up at all, it's really unusual. Most volcanoes give you some warning. There's earthquakes, there's steam that comes out. Every once in a while, boom. No warning at all. Yeah.
Do they know why?
No. This is a really puzzling eruption. Don't know why. And this Plinian column went on for several hours. Made a real mess in Anchorage. The prevailing winds dragged this material right over Anchorage, Alaska, which is, I think, about 70 miles away. Made an awful mess. But yeah, no warning at all. Really, really strange. Okay. Now we have probably the most energetic of all the eruption types, ultraplinian. These are Plinian eruptions on steroids. When we talk, you've heard the term supervolcano, this is what they're talking about. Ash columns that go up 30 miles or more. Remember, when you're in a jetliner, you're up about 5 or 6. You're at 30,000 feet. We're talking to the upper reaches of the atmosphere with these eruptions here. Typically, this is where calderas come from. The eruptions are so big, so energetic, erupt so much material that the chamber evacuates and the volcano falls in on itself, creating a big crater or caldera. The columns are huge, but there's so much material coming out that they typically collapse into huge pyroclastic flow sheets that weld back together. These welded tufts are sometimes called ignimbrites. Just another term for a really thick, welded pyroclastic flow. The eruption rates are off the chart. 100,000 cubic meters per second. Coming out at supersonic speeds. Yeah, the material comes out of the top of the volcano at about the same speed as a high-powered rifle. A couple thousand feet per second. So lots of power, but lots of material. So sometimes the weight of the material that's being ejected is more than the force of the eruption can sustain, so the columns collapse and form huge pyroclastic flows that come down the sides of the volcano and spread out in all directions. I'm going to send you an email tomorrow with a link to a video that I want you to watch about Pinatubo, which is an eruption in the Philippines in 1991, where they had ultraplinian eruptions, and it talks about the lead up to that big eruption and the volcanologists who worked it and were in charge of trying to predict it and the difficulties they have. To me, it's still probably the best volcano video out there, but What happened with Pinatubo was the same thing that happened with other caldera-forming eruptions, is that the columns were so big and had so much material that it collapsed and formed huge pyroclastic flow sheets that actually came towards the volcano observatory while they were all still working in it. They had instruments between themselves and the top of the mountain, and they watched the instruments just go dark. So they were probably being taken out by pyroclastic flows that were moving towards them. And they were worried that the pyroclastic flow was going to hit the observatory, which was actually located on an Air Force base that we had in the Philippines. So it's an interesting video. But you'll see what an ultra-Plinian eruption and the lead up to an ultra-Plinian eruption looks like. It's a good video. I think you'll really like it. So we've had some older eruptions and some recent eruptions that fall into this. Krakatoa, back in 1883, is one of the most well-known of the ultra-Plinian eruptions. This was a caldera-forming eruption on a volcanic island off the coast of Indonesia that collapsed into the sea and sent a tidal wave that went around the Southern Ocean twice. It was recorded to be the loudest sound ever produced on Earth. They could hear it in India. It was deafening in India. But what was weird is that people that were near the eruption didn't hear it. So there was some talk about whether the sound actually bounced off one of the higher atmospheric layers and came back down, or just how it worked. But the people near the eruption didn't hear it, but they heard it 2,800 miles away in India, and it was really loud. So this was an amazingly large eruption. There's been books written about it. Long Valley Caldera, which is a volcanic feature in eastern California that's about 600,000 years old, would fall into this category. The Yellowstone eruptions would have been ultra-Plinian. Taupo, New Zealand, another large caldera, would have been ultra-Plinian. Tambora, which erupted in 1815 in Indonesia, erupted so much material into the stratosphere that it blocked out enough sun that they had snow in parts of sub-Saharan Africa, massive crop failure in Europe. This was in 1815. The next summer was so dark and gloomy that it was called the year without a summer. And it's actually the year that Mary Shelley, an author, wrote the book Frankenstein. They attribute the gloom and doom of the English summer to her mood when she wrote Frankenstein. So Frankenstein may actually be linked to a volcanic eruption. So we've had some big ultra-Plinian caldera-forming events here in the U.S. Crater Lake is a great example. Any of you been to Crater Lake? If you get the chance, go. It's really a spectacular place that's easily accessible. Formed at ancient Mount Mazama, which was probably a 14,000 foot peak in the Cascades, so about the size of Mount Rainier. Enough material was ejected during this eruption, which was about 8,000 years ago, that it evacuated the chamber. The top of the volcano collapsed into the volcano itself, left this gigantic crater lake. There's been some activity since the caldera forming event that formed that little island and lava flow out in the middle called Wizard Island. This is one of the deepest lakes in North America. I think it's 1,600 feet deep. So caldera is a deep structure, huge. It's 6 miles across. Beautiful place. But Long Valley Caldera down there in the lower left, eastern California, spread ash over much of the southwest and central part of the U.S. Yellowstone not really listed in here, but covered good parts of North America with ash. So these are the biggest of the big in terms of eruptions. Okay, let's stop there.